You've dealt with data before, and you probably are used to thinking about different data types. But one of the differentiations that we're going to move into going forward is thinking about primitive versus complex types, or primitive versus object types. And so if you have seen these sorts of types before in Java or in a similar language, you may have seen primitives like int, boolean, uh, doubles, and things like that, and objects like a string or a scanner, or maybe you've even done things with files before. And that will give us some room to start to think about what are the actual differences between primitive types and object types in Java, or probably in just about any language that you might have dealt with before. So take a moment and think about that. Pause the video and think about your answer. What are the differences between primitive types and between object types, particularly in Java, but in any language that you may have seen them in? Pause for a moment. One surface level thing that you may notice is different in Java is the convention that primitive types are listed where the type name is all lowercase. So that's an easy way to identify them if we're looking at different pieces of code, whereas the type name starts with an uppercase character in the case of complex types, object types. So that's one difference that's sort of easy to spot in the code. Another difference that you may have seen before is that in primitives, we can compare with equal equal, and it works the way that we want it to, whereas with complex types, we usually have to call an equals method, like dot equals, like when we have two strings and we compare them. And along those same lines, we can call methods in general using an object variable. Like we can say s dot uppercase or to uppercase or something like that. So we can call methods on them using that variable. Those methods belong to the class that that object comes from. It's a whole thing that we'll learn more about later, but in general, we can call methods like that, file dot something, these sorts of things. Whereas you can't do that with a primitive type. If you have an integer x, you can't say x dot minus or anything like that, or x dot toString or something. You have other ways to go about doing that. One thing that you may not have encountered before, or that may not have struck you as a fundamental difference between these, is that if I create two variables of primitive types, int x and int y, and then if I say x equals y, that actually copies the value. Whereas if I say x equals y, this makes them the same reference. What that means is that object types in memory actually get stored as a reference to something bigger, whereas primitive types, if I had something like an integer x and y, a primitive type gets stored as its actual value in memory, and an object type gets stored as a reference to some bigger space in memory. So if I create an integer like x and I set it equal to 3, the number 3 actually gets stored at the slot in memory that's allocated for x. I'm going to go back and change these to a and b so that we can tell that they're a different thing than what I'm talking about. So if I create the integer x, and I set it to 3, 3 gets stored at that line in memory. Then if later I create the integer y and I store the value, or if I say x equals y or y equals x, either way, let's say y got 6, and then I say x equals y, that changes what's stored at the x line. It copies the 6 over into that line. Whereas if I create something like a string called A, what it's going to do is it's actually going to give a memory address that points somewhere bigger in memory that might store lots of things, because strings are a little too big to store on a single line. Files are too big, and lots of other types that we're going to examine that are object types will need some bigger box in memory. So the way that Java does that is it stores a memory address. And let's say it will be in hexadecimal, where it will have that weird 2A kind of thing that you'll see places. And then I might create a string B. And if I say B equals A, then what that means is B will get the memory address that points it to the same place as A. And so that points them to the same exact thing in memory. So if I were to change something, let's say they're both scanners, and I read forward using A, I say A dot next line, and I read to the next line, that will precede B onward to the next line as well, because they are pointing to the same thing. You can think of it as being like nicknames for people, that if I say Steve went down the hall and my buddy went down the hall, and everyone knows I'm referring to Steve, then we assume that those refer to the person that is that same exact item, that same exact reality of a person, instance of a person there. So primitives are stored by value, meaning the actual value gets stored in memory there, whereas objects are stored by reference. We reference to something bigger in memory. It points away from that line in memory to somewhere bigger. For technical purposes, that bigger space of memory where lots of big objects can be made is referred to as the heap, and the smaller space in memory is referred to as the stack. We may or may not understand that premise by the end of this course, but it may be useful for you later on to know those terms. So when I create objects, I'm actually pointing to some place outside of that line of memory. And so what you're going to do today in your activity is to explore a little bit with these ideas of primitive and complex types or object types, and how they can behave a little differently, what things about them will be the same, when they might look the same on the surface, but behave differently too, like how we can call equal equals on an object, but it gives us different behavior than calling dot equals, as you may have seen in the past with strings. So keep these ideas in mind as you move forward to working on section A of the objects activity.